Hi there, I'm Tom Maratz. I'm the project lead for the Residential Home Diagnostic Systems entry as part of the IoT challenge. I just want to take a few minutes of your time to go over the project with you. But before I get into the technical stuff, I'd like to give you a bit of a background on the team members and why we got into the challenge. The team itself consists of three guys. There's myself, Larry, and Dan. Between the three of us, we've got some electronics and computer science backgrounds. Larry and myself, we work in the smart energy, eco-energy space, so we're dealing a lot with energy efficiency related matters for small business and homeowners on a day-to-day basis. As for why we got into the challenge, it's something that caught our attention when we were reading up on the challenge, and it was this idea that you can use open source technology to make it easy to build an IoT solution, and that certainly sounded good to us because we've been wanting to build this system for some time, but really who's got the time and the know-how to put together a system to solve a complex problem? And there's a lot of complex problems out there. For example, in our particular area of smart energy, looking at ways where energy efficiency can help to reduce greenhouse gas as an example, and we all know that many hands can make for light work. And so I think really that's where open source IoT comes in, is that this collaboration effort with sharing of software and technology, open standards, and we just wanted to be part of that. We want to be able to contribute, see what we can do to help make things a little bit better for all of us. And so that's why we entered the challenge. Okay, let's get on with the technical side of the project. What we're trying to do, the overall goal, is to improve the energy efficiency of a home. And the way we want to do that is build a little, energy modeling system that's going to be able to measure the heat loss across the building envelope, which is just the outside exterior of the home. And then we want to be able to get that information on heat loss up to the homeowner and to service organizations or to the experts that can process that information and figure out, if any improvements need to be done to that home. So why are we doing this? Because heating and cooling is typically the largest expense incurred by most homeowners. So if we can improve the energy efficiency of the building envelope by being able to monitor what's going on, then we should be able to reduce the carbon footprint of that home, and that's of course good for everyone. Now the project is really based off a simple formula. This is the conduction heat loss formula, and it's a way of calculating heat loss across a building envelope. It has some variables here, but these are basically constants. It's basically, we'll be able to just input them into the system, or into the formula rather, and what they do is they determine the conductivity, the thermal conductivity of the materials used in the walls, the surface area, and the depth of the insulating material. What we're really after is the delta T, the change in the difference in temperature between the inside and the outside environment. And so once we understand that, we can monitor that on an ongoing basis, then we can have a real-time value for the heat loss, or Q here, of that home. And again, that information in the right hand can be pretty valuable, because you'll be able to do stuff like figure out if retrofit work, energy efficiency measures make any sense for a particular home. And studies have shown that improvements can reduce the carbon output of a home by 60 to 80%. You'll be able to validate retrofit work. So if an organization comes in and does some work, you'll be able to measure the Q before and after, and basically be able to see the difference and whether or not the improvement made any sense. We'll be able to figure out stuff like whether or not your heating and ventilation, the air conditioning system, your HVAC system, how it's performing. Is it oversized, undersized? Oversizing and undersizing is a big issue in the industry. So again, we'll be able to look into stuff like that and figure out whether or not the HVAC is performing well. And of course, the more the system runs, of course, the more energy it uses, the bill goes up, and of course, so does carbon output. And again, and I think as well, if we got a better building environment, it's going to be more comfortable as well for the homeowner. So in a nutshell, that's essentially what we're trying to do. So we're pretty optimistic that we'll be able to create a more efficient building envelope if we're able to monitor this queue and get it into the hands of the right folks. So that's essentially the project. We're really hoping that this is going to work out for us, and that we can really create a building environment that's, how do I say it, more adaptable and responsive to the outdoor conditions. So I hope you'll follow along with us. This is where we're starting. We're designing and building as we go, so things are going to change pretty fast as we move forward. So I'm hoping that through this project, maybe some of you folks might be motivated to undertake your own IoT project someday, because I think that, hey, if we can do it, you can do it too. So till next time.